Our next session is titled Why Evaluation Matters. We are honored to have Mr. Sanat Joshi, EVP from Appian, to present this session. Mr. Sanat is the Executive Vice President of Product and Innovations at Appian, where he leads the company's product organization focusing on enterprise process automation, AI, data fabric, and industry specific applications. Prior to this, he has taken on multiple leadership roles in AWS, Oracle, etc., with a strong track record of building and scaling products. Before we have Mr. Sanath on stage, there is an interesting AV to be played. So afterwards, we'll invite the gentleman. Can we have the AV, please?
We knew that we needed to have a much better digitally enabled workforce. We selected Appian as the best technology to do that. Immediately after going live on Appian, we had a 30% efficiency saving.
Appian gave us the flexibility to build everything we wanted in the way that we wanted it.
AI on the Appian platform has enabled us to do things and automate some of the work that is a barrier to care. We were able to reduce the time of onboarding to just 4 days from a 6-month average.
Aspire will be able to reduce our cycle time by 55%, and our estimate is that $42 million of misaligned capital could be avoided and repurposed.
We've onboarded over 3,000 clients with Appian. We've had more than 3x growth, and we haven't had to grow that much in personnel.
Prior to working with Appian, we put together our contracts in a very manual process. After acquiring the Appian system, our awards are now automated.
The world is always changing, and Appian allows you to evolve with it.
With this interesting video, ladies and gentlemen, may we please invite Mr. Sanat Joshi to join us on stage and take over the session. Please, sir.
Well, this is a fantastic event. The morning sessions were just incredible. Inspiring is really the only word I can use to describe them. And what a sense of fantastic development and what interesting times we live in. So this morning, what I was thinking of doing was talking to you about, AI deployments in the enterprise. But let's start with a little bit of introduction about Appian, so you can have some context about what we do. And then from there, I'll try to connect it to the morning sessions and where there might be some connectivity and some opportunities for the field to really progress. So Appian, our business is to make process more efficient, right, in the enterprise. And so enterprises really are made up of business processes. And when those business processes work better, then the organization as a whole becomes more efficient, more profitable. They can deliver whatever their promise is to their customer. And so we have examples of working with customers like Novartis on delivering drugs faster to market. That's a business process. You have people getting loans from financial services institutions, and that loan processing is very time consuming. And so those are business processes we help automate. Or when a company like Jaguar Land Rover is working on a supply chain issue during the COVID pandemic, when parts were really at a big shortage, we stepped in and we helped them improve their process. So that's another good example of a practical application of process automation technology. And then governments use Appian to become more efficient to serve their citizens more effectively. So, wherever you look, whether it's a hospital, whether it's a bank, whether it's an insurance company, you see a business process, and then wherever there is a business process, there is an opportunity to improve that. So that's really what we do. And we do this with, very, very well-known companies, big and small, across the whole world. I will try not to make this a marketing presentation, but I just wanted to give you a little bit of introduction about ourselves. We are, at the end of the day, a process automation platform, so we've incorporated many, many different technologies, such as a data fabric, which is to bring together data from across the organizations because processes run on data. We have automation technologies such as robotic process automation, rules-based automation, and now artificial intelligence that's part of the platform. And ultimately, when people engage with computer systems, there is a user interface, And so we take pride in developing really beautiful, delightful user interface. So that's the platform. Um, and more, of course, AI is becoming centerpiece to what we do. And we've taken a very different approach to artificial intelligence. Because our customer base is highly regulated industries, they don't really have a lot of appetite for variability. Now, you heard this morning, about transformers, about deep learning. At the end of the day, these are technologies that really are probabilistic, and enterprises want deterministic processes. An interesting anecdote I'll give you is I was working with the chief operating officer of a very large insurance company in the US, and we are working with them on AI application. We are seeing some success, but in the claims process, he made a very simple statement. He said, not a single dollar will leave the organization approved by AI. I want a human being in that process approving AI because, at the scale at some of which these organizations operate, even if they are operating at 5 nines accuracy, that's still not good enough. So Appian's approach has been deploy AI inside a process, similar to how you might deploy human beings inside a process, and then you can have checks and balances. And we like to say the process provides AI with a goal, it provides AI with some structure, with governance, with guardrails, and then use AI what it's best for. Where you want variability, you want to handle variability. AI is really good at it, but if you just want a calculator in the process, it's probably not a good idea to use AI to act as a calculator because, again, it's probabilistic technology. And then finally, the process also provides measurements and accountability. And that's where I'm going to segue into the next part of the discussion, which is when enterprises are trying to deploy AI into processes for real practical purposes, what happens? What are the issues they run into? And after listening to this morning's discussion, the fantastic presentation from Dr. Gupta and Professor Mohan, to me it feels a little bit like, AI, the state of the art might be, at least in research, might be like somebody playing Beethoven, or it's even Beethoven composing music. And then in the industry, we are still singing Baba Black Sheep. And how do you kind of bridge that chasm, right? So that's what I'm going to focus on. And I'm going to talk about some practical ways industry is approaching this. But we are having this discussion under the auspices of the CMI. So I would also challenge academia to help industry think about and how do we solve it. And so the title of this discussion is Why Evaluation Matters in Enterprise Application. And so as people are creating AI applications, they are deploying AI agents now. It really feels like you're flying blind. You might have seen the movies about, the pilot has no visibility and they're flying through a snowstorm. That's how it feels like. And you see examples after examples where even after a lot of tweaking, your models, you celebrate when you achieve 98% accuracy. And that's just not acceptable. And a lot of times there is no explainability to these models. You don't really know what happened. When you change from model to model, you see models skew. Governance is a problem. And then some fundamental techniques that we've figured out over the years in deploying computer applications, such as testing, quality control, those are just missing. And so organizations are spending billions of dollars in researching stuff. I mean, there is a famous MIT study, like 95% of AI deployments, there is no ROI. And so that's the shocking statistic. That's a really scary statistic. Even during the cloud, years, even in the beginning dot-com bubble, you saw a lot bigger ROI than what you see today. And so that's the problem statement. And so that's where evaluation comes in, right? We're trying to create an engineering discipline that bridges the chasm between demos and production systems. And today it literally is a chasm. So, and this is where I think a lot of development, a lot of R&D needs to happen, because today you can't really say it's a science. You cannot even say it's a technology. It actually is a technique and methodology that industry we are trying to hack together. We are getting pretty good at it, but a lot of work is needed here. So when you just look at what is an AI agent, you have to first figure out what are its core components, right? So think about an AI agent where you are saying there is an inbound email, read that email, go look up data, say it's a customer record, it's a customer service request you are getting by email. So go read that, figure out who the customer is, look at their record, and respond with an appropriate response, right? Very, very simple task. So what's involved in it? There is typically a router, which is a large language model. So whether it's Anthropic's Claude or Google's Gemini or, of course, OpenAI, these things are getting really good at agentic behavior. That's being baked in at some layer of the model. And so you can think of it as a router. That's a router that's interpreting the natural language request, and then it's figuring out what to do. So it creates a plan. And then from the plan might say, okay, you have the email coming in, interpret that email. So it's creating the intent. And then from there, what tools am I going to use? So a tool could be go perform a query, a SQL query on an Oracle database. Say that's the skill you are going to use. And then finally, after the result comes back, it may take a next step or it may close out the action. And all of this is stored in short-term memory and then increasingly in long-term memory. And the memory structures are actually, it's a big word, but it's fairly straightforward. It's some kind of persistence for the activity happening, right? So that's the basic anatomy of an AI agent. And so when you think about these AI agents, the router is what acts as the boss, and that's where the magic happens. So when the large language models announced agentic behavior, and then there was a famous discussion around the software world is going to change because of AI agents, that's when industry woke up and said, this is my opportunity to cut my staff by 90%. There is now even talk of, similar to how you would have people-less factories, lights out factories, dark factories. We are going to have companies that have only a few people managing these agents, right? So some of this is daydreaming on people's behalf, but there is a real opportunity for us to see efficiency. But that efficiency happens because of this router or this planning engine that you see in LLMs. And then it starts with two things. One is, what skill do I use? There's a technique that's called tool use. That's what it really involves. And then, am I passing the right information? And typically, that's today JSON. JSON is the payload for the IT practitioners in the audience. You do this every day. And so that fundamentally is what happens there. But these skills, these tools, are really the important building blocks of agent. And if you have the right tools, if they're structured the right way, and now MCP is the protocol that the industry is standardizing on, then you can build agentic systems that can perform some real work, and then at least in the laboratory or in prototypes and pilots, you see really, really impressive results, which is again what describes the phenomenal enthusiasm and excitement that the industry has about this stuff. So you can think about a process flow that has 10, 20, 50 steps, and each one of these steps could be a tool. But even when you take a part of a process that just has 3 steps and 3 tools, you see that evaluating those skills and their performance requires many different techniques. So for looking up data and finding the right data, there is a technique called RAG. Again, it's become commonplace now, but the retrieval augmented generation, so without actually having to read massive amounts of documentation or look up all the data, you are essentially finding a vector index and then getting just to the right data, just in time. So that's really what RAG is. Uh, so that's one technique people use. The other technique that people are using is use a second LLM as a judge to evaluate whether the skill executed correctly. So what I'm just trying to get to here is this is not something IT and industry is really used to, right? This is new. And these techniques have not yet become, well understood. There is not really good tooling around it. And so we're going to have to figure this out. The other important issue is the LLMs tend to sometimes be forgetful. So the techniques for them to remember, although they are getting better, are not perfect yet. So practitioners have to augment the LLM's memory with your own memory structure, and you have to think about short-term memory and long-term memory. And so this simple example here, which is somebody searches Google, I'm looking for a flight from Chennai to Tokyo. And so the LLM might come back and say, I found several options. What dates do you want? And then you said, how about next month? Now, if the agentic application doesn't have short-term memory, it doesn't understand the context of how about next month. And you should go home and experiment with several search engines, Google, Perplexity. You will consistently find very interesting behavior when you say, how about next month? If it's location aware, it might give you all the festivities and events in Chennai next month. So these things, memory management, when you deploy these things in the enterprise, is a big challenge, and you have to think about that carefully. Now assume that all that is working well. I talked about the boss, the router. So the router itself is what's defining the path. So if you remember the picture I showed you of a process model, a deterministic process model, every step is determined, right? And you might have an XOR where you might be making a decision. If this customer has a claim that is valid and they have a valid policy, then you route this way, otherwise you reject the claim, that type of thing. With LLMs, with agentic systems, what happens is the path that is determined, that happens dynamically. In a way, that's the real superpower of LLMs and agentic systems. On the flip side, that is also their biggest weakness. Because even a given LLM, the same model with the same data set, may or may not generate the same path if you run it 10 times in a row. Now, if you use a different large language model to do the same application, it might behave totally differently. And so you're trying to deploy a process or an application in an enterprise, the first thing you want is reliability. Because at the end of the day, reliability is what provides for better customer service. Companies are run for profit, and so the variability is really unacceptable. And so that is the other failure mode that we see in agentic systems. Now there are solutions for it, but I'm just trying to walk you through why evaluation is important. So there is a concept called convergence, which really means measuring the number of steps and then are you following the right pathways and the consistent pathways. And even today, right, we ran an experiment between an OpenAI model and Anthropic's Claude, the latest model. This was run about 6 months ago. We saw a lot of divergence, actually, not convergence. So you have to be aware of that if you're deploying an agentic system. And finally, for you to be able to test, debug, and deploy an agentic system that is reliable, especially for mission critical processes, what do you have to do? You have to know all these different steps and failure points, and then have tracing and logging across that entire stack. So that's where tracing becomes a critical part of evaluation architecture. And therefore, a central platform for AI tracing and evaluation becomes a critical path if you're going to start deploying AI applications at scale in your company, or if you're a software company like we are, this becomes a very important part of our foundation, where you have unified tracing and evaluation, you can enable robust testing, and then you are going to provide the flexibility for a variety of AI applications, whether they are agentic applications or whether they are simple step applications like document processing. Here is a schematic. I'm not going to talk about each single block, but fundamentally there are 4 parts to a standardized tracing and evaluation platform. One is where your applications, your agentic and other AI applications live and they execute. Then you've got the telemetry, so where you are generating the traces and you are ingesting that telemetry. Then you have a component which is really driving the execution, and then there might be a feedback loop. And then lastly, the most important part is the evaluation component, and we'll talk about the evaluation component now. So this is a general purpose architecture. It's really not that complicated, and you don't have to build it yourself. You can go pick up a framework, an open source framework like Langfuse or Phoenix. There is a bunch of these out there. But as a practitioner, it's important for you to understand how these things are, composed and what are all the moving parts are. So you can pick the right framework, and you can basically customize it and modify it for your own needs, because you don't need all of this. It just depends on your application. But even after you put in such a framework, what's now missing is a methodology. So in traditional enterprise IT, we really understand quite well now how to do code scanning, how to do performance management, how to do debugging, how to do testing, what test coverage means. All these techniques you have to throw out the window, and you have to say, how do I think about it for agentic systems? So you think about the pre-production phase or the development phase, where you are going to establish some ground truth. Then you are going to basically, throughout your development cycle, you are going to use that ground truth, the golden data set, to ensure that what you are developing, every feature you add does not actually cause a regression, and you kind of keep up the quality. And then finally, in production, you want to monitor your models, their performance, your AI application, and ensure that there is no skew or regression that's happening. So the first step is, and this is where you see companies like Scale AI that Google acquired. There are a bunch of these out there, and they're making a fantastic business out of creating ground truth and golden data sets, annotated data sets for training LLMs. But you need the same thing for your AI application. Why? Because the large language model has not been trained on your data set. It's been trained on a generic data set. And so when you apply it to your own situation, when you want to evaluate the performance of your application, then you need to have a data set that you are feeding it. Now, this does not need to be massive, because techniques like few-shot prompting have really become quite effective. But fundamentally, you need a golden data set to say, what does good behavior look like? Whether it's document extraction or whether it's some other AI application you have to be able to say what good is, and we can talk about how to annotate data sets so you differentiate between good behavior and bad behavior. A technique that is becoming quite successful is creating synthetic data sets. So synthetic data sets, you can then annotate yourself, and you can use those as input and to steer the model in the right direction. Now, when you create that golden data set, what you need to do is how do you automate whenever you have a execution, a run, whether it's in development, testing, or actual production, how are you going to compare the outcomes to your golden data set or your baseline? Now, a lot of companies, we see them just using manual techniques. And of course, manual techniques don't scale because remember, we want to deploy these systems for production use, and thousands, hundreds of thousands, sometimes millions of processes are going to run through these processes. And so therefore, you can't really do this manually. And so you have to develop automation techniques to be able to compare output to the baseline data. So we call that evaluating the evaluator. Then, as I mentioned, within development, you've got to, every time you develop a feature, you have to get into the practice. And so in traditional software development, it's called CI/CD or your DevOps. That's the pipeline that takes an application from development all the way to production, first through testing and then production. So with AI applications, it's the same thing, but now you have to ensure that you are using your golden data set and then compare outcomes and output against that golden data set during the development process, and you should develop tooling to do that. In traditional software applications, the tolerance for outcomes that were not exactly to the baseline was basically zero. If I'm just trying to do, add up two numbers, the answer always needed to be 2 plus 2 is 4. With these probabilistic systems, you have to also realize that you have to account for variability. There is, as I said before, between 95 to 98% accuracy often is the best you are going to get. So that really requires a big mindset shift. So when you're, and we often see customers making the mistake of trying to fine tune and continuously try to improve the accuracy to get to 100. They never get to 100. They never deploy those systems. So you have to think about techniques such as maybe 98% is good enough, and you just can deploy either a second LLM or a human in the loop if your tolerance for inaccuracy is really zero. So reading the results, as it says, it's not black and white. And then ultimately, this problem doesn't go away when you have deployed this hard work into production, because even after deploying it in production, the large language model providers continue to improve their models. And sometimes even within the same model version, you start seeing queue. Suddenly you wake up one morning. I'll give you one example. We had a Department of Defense customer. We had deployed a system to, and there was a lot of, data about arms and ammunition. One fine morning, the cloud provider and the LLM we were using, they decided that that was sensitive information, and the LLM started responding, hey, I'm not allowed to talk about whatever is in this document. And so that stuff happens, and ideally what you want to do is have real-time protection, guardrails, and cross-checks, so you can alert yourself to this, and then you can control for it. So these are the issues and some of the techniques that people are able to use. And ultimately, what is the goal? The goal is a self-improving evaluation system where you've got a robust framework and tooling for testing AI applications, in the R&D phase, in the development phase, in the testing phase, and then ultimately in the production phase. And then where the next step is, as you kind of go back and correct the AI, you provide feedback to it, you annotate the data, you annotate the outcomes, then you want the AI to remember all of that through long-term memory and then feed that back to the large language model so that it becomes self-correcting. So it's a system that's continuously improving without human intervention. And so that's the goal. We are getting better at it, but as I said before, it still requires a lot of expertise from services companies, from software companies. And so there's a big opportunity for research to happen so we can get AI from demonstration to production and cross the chasm. So that's really all I had. I'm happy to take questions. There are.
Thank you, sir, for the fantastic session. In evaluations, right, the pyramid technique that we use in industry is that LLM is the judge, right? Now, my question is on, in multiple scenarios we used, often like this judge LLM, it makes a mistake, right? I mean, even the primary LLM makes some correct decisions. The judge says it's incorrect, right? So how do you recommend, or what is your recommendation for picking up the judge LLM or judge agent process?
Yeah, so that's a really good question. So a technique that's become popular is using a second LLM as a judge. So I will give a simple example. Document, entity extraction or information extraction from a document is probably one of the most popular use cases where we are applying AI today in enterprise. Now, when you've got a complex document, the large language model might work 90%, 95%, 98% accuracy, and you don't really know when it's hallucinating or when it's getting it wrong. And so oftentimes you will deploy a second large language model as a judge. So the technique that we've learned over time is, firstly, don't use the same LLM as your judge. Try to pick another compatible LLM that generally provides good answers. The second technique that we have learned is, typically you will find out where the LLM makes the mistake. So focus on sampling and don't try to get it to, do the full comparison. Otherwise, you're going to get into the problem of trying to get to 100%, and now you're going to spend time trying to reconcile the responses from the two LLMs. So basically, we would say pick the second LLM. All LLM providers have two types of models. They generally have fast models and they have a slow model. The slow model might be more accurate. So for the judge, generally pick the fast model. It's also less expensive. And generally speaking, they do a good job.
Hey, hi, Sanat. Avinash here. Apologies for my sore throat. It's a really great session. I have a question. Let's say when we are designing an evaluator, okay? Now, it's really easy to design an evaluator when the output is only a good behavior and a bad behavior. But let's take the case of this process mining, where every industries are going to have a different variants of process which will work for them. So you cannot just generalize this is a good behavior for your organization or this is a bad behavior for your organization. Then how do you design that evaluator which will work differently for a different organization? How you generalize that?
Right. Yeah. So I think I can actually generalize the question first. AI applications in general, it's really hard to say, I'm going to create one and then I'm going to apply it to any customer. The simplest of examples is customer service agents. The use case is fairly well understood, right? You've got a corpus of data where you've got customer service records. In some companies, they go back 20 years. And so I've got, a customer service chatbot that I have trained, and it should be able to read that data and, provide good answers. What we are finding is you have to basically fine-tune it, not in the technical sense, but you've got to basically train it, prompt it, so it performs well for your situation, for your own data set. And it's the same thing with evaluators. When you create an evaluator, you first have to think about, what modality you wanted to use, because the modality matters. Is it text? Is it video? Is it images? You also have to train the evaluator, similar to training the primary application itself, on your own data set. Otherwise, it doesn't perform well. The takeaway there is, I think AI applications are going to bring a lot of fantastic business to service providers, because you could take one AI application and you can't really pick it up and go deploy it to the second customer. You have to do work to really customize it for that second customer, and evaluator systems are no different. So with that, thank you very much.
Thank you.
I appreciate it.
Sir, one second. May we request Professor Madhavan sir to join us and present a memento as a token of gratitude, please, sir. And ladies and gentlemen, one more time can we hear it for Mr. Sanat Joshi for an engaging session. Thank you, sir. Thank you so much.